Good morning students. Today we are going to start chapter 5 and the chapter 5 is your laws of motion. Now the first topic which we are going to discuss is your force. I think most of you know what is force. So let me read out what we have written. Force is an external effort which either changes or tends to change the state of rest or of uniform motion or direction of motion of the body. So you see, force is an agent which changes these parameters. These parameters means state of rest to motion or motion to rest or change the direction. The agent which does these things, which do basically these things, can be defined as a force. Now next let me define inertia. This one also you know. The inherent property of the body by virtue of which it cannot changes its state of rest or of uniform motion along a straight line by itself is called inertia. So everyone have inertia. So like the object also have inertia. So if an object is in motion, it always tries to maintain its motion unless an external force is applied on it. Or if an object is at rest, it always tries to be at rest unless an external force is applied on it. So if there is no external force, an object in motion always maintain its motion, or if an object is at rest, always maintain its rest, and this property is known as inertia. And this is inherent property because we also have inertia. Now regarding the classification of inertia, number one, inertia of rest, inertia of motion, and inertia of direction. So inertia of rest is nothing but the inability of the body to change its state of rest without the help of external force. Similarly, inertia of motion is the inability of an object which is in motion to change its state of motion without the help of an external force. So inertia of direction, if an object is moving in a particular direction, it always maintains its direction unless an external force is applied on it, and that is nothing but the inertia of direction. Now the next part which we are trying to define is your momentum. So momentum also you have got in lower class, maybe class 9. So let me read out. Momentum of a body is the quantity or amount of motion contained in the body. So if an object has a high velocity or if an object moves with a high speed, it means its momentum is high. Okay, and momentum is nothing but the mass into velocity. So momentum basically measures the amount of motion contained in a body. It is a vector quantity and its SI unit is your kg meter per second. Now let me go for the Newton's law. So Newton's puts forward three laws: first law, second law, and third law. So first law can also be known as law of inertia, or you can say first law basically define the definition of force, because first law says it is the force which changes the state of rest or state of motion of an object. So let me read out what you have written. Every object continues to remain in its state of rest or of uniform motion in a straight line unless it is compelled by some external force to change its state. So force is the agent which changes the state of rest or state of motion of an object. That is the first law. Now the second law, the rate of change of momentum is directly proportional to the impressed force and takes place along the direction of force. So this is your second law. So we are trying to define the expression. If F be the force and P be the linear momentum, basically momentum is denoted by P, then as per the second law you can write F proportional to dp dt. dp dt is nothing but the rate of change of momentum. So if you want to bring one constant, you have to if you want to make proportional with equal, then definitely you have to bring one constant. So k is your constant, we have written, where k is the constant of proportionality. Now momentum is nothing but is your mv, mass into velocity. So k ddt of mv, so m is constant, so m comes out km dv dt. So dv dt is nothing but the rate of change of velocity, so it's nothing but the acceleration kma. So in mk system or in system of unit, basically SI system of unit or mk system, k comes out to be 1. So ultimately you will get F equal to ms. So this formula is very important for the numericals. Now third law, all of you know, every action has an equal and opposite reaction. So there are many examples related with the Newton's law. First law means the law of inertia. If a bus suddenly moves, we used to fall backward because we want to maintain the inertia of rest. Or if a bus is moving, and if suddenly stops, then we fall forward. That is due to the inertia of motion. So like that, many example. The second law is also there. It's nothing but the measure of the momentum. So there are many example. And third law also, recoil of the gun. That is, there are many examples. You please go through the textbook if you want to go for the application part. Now let me try one numerical based on this definition F equal to ma. So a force F vector equal to 10 I cap minus 6 j cap plus 8 k cap Newton produces an acceleration 1 meter per second in a body of mass m. Calculate mass. So F is given. So let me try to find out the magnitude. Again we have to go for the vector part. Coefficient of I cap whole square plus coefficient of j cap and coefficient of k cap. 10 square plus minus 6 whole square plus 8 square. So 10 square means 100, 6 36, 8 64, 64 36 is 100, 100 100 200, so 10 root 2. And then also F equal to ma. So in place of F, let me write 10 root 2. M already knows, and A is your 1, so it comes out to be your M equal to 10 root 2 kg. So this is all about. Please go through the details if you want to go for the example part in your textbook, and put your doubt. If you have any doubt, you are free to ask. Thank you.